Hey guys, let's take a look at some more multiplying fractions. So if you remember from last time, we did the rectangles and we split them up based on what the two fractions said. And then as we walked through, I asked you to look for patterns that you noticed, and we came to the conclusion that when you're multiplying fractions, all you do is multiply the two numerators together and multiply the two denominators together, and that's your answer. However, you have to check at the end to see if you need to reduce. Okay, so let's do one here. So 3 times 9 gives us 27, and 4 times 10 gives us 40. All right, so the answer to this would be 27/40. Now think, can you reduce that? So you might ask your question, well, does 2 go into both of them? No, 27's odd. Does 3 go into them? Well, it goes into 27, but not 40, because 4 plus 0 is 4, and 3 doesn't go into 4. No to 5, it does go into 40, but not 27. No to 6, because we didn't have 2 and 3 for both of them. No for 7. I honestly forget the rule for 7. I just know that 7 times 4 is 28, so 27 is not good, and 7 times 6 is 42, so 40 is not good. We could keep going doing this, but hopefully you'll realize that there's nothing that they share in common. All right, so this is our reduced answer. All right, let's do it again for the next one. All right, you take a second to go ahead and do that. All right, so hopefully you got 9/40. All right, so we can kind of use what we talked about here for seeing if they share common denominators. It can't be reduced by 2, yes to 2, no to 2. Can't be reduced by 3, yes to 3, no to 3. Can't be reduced by 4, yes to 4, no to 4. Actually, now that we know that 2 doesn't go into 9, we don't have to check any even numbers. So then we would say 5, no, yes, 6, no, no, 7, no, no, 8, yes, no, 9, yes, no. And then anything that gets bigger than that is too big. Bigger than that is too big. Okay. All right, number 3. What do you think? Hopefully you got 1/16. 1 times 1 is 1, 8 times 2 is 16. There's nothing that's going to reduce there. All right, let's take a look at number 4. I'm hoping to get the first 10 done and then let you get the next 11 done. All right, so 1 times 1 is 1. 2 times 3 is 6. Again, the only factor that they share in common is 1. So it won't reduce. Okay, next one. All right, numerator should be 3, denominator should be 28. So if they're going to share a factor at all, it has to be 3, because 3 is prime. So that's the only factor. So does 3 go into 27? Answer would be no. 2 and 8 is 10, and 3 doesn't go into 10, so that's it. All right, number 6. 1 times 2 is 2. 6 times 5 is 30. All right, again, 2 is a prime, so if they're going to have a common factor, it has to be 2. So does 2 go into 30? Yes, it does. All right, so 2 goes into 2 one time, 2 goes into 30 15 times. That one actually reduced. I'm going to put a little circle around that because I want you to pay attention to the ones that do reduce, because when we come back from break, that's what we're going to talk about, is how we know when a fraction reduces or when a product will reduce. Okay, number 7. 2 times 11 is 22. 3 times 12 is 36. Think about that for a second. Will it reduce? Hopefully you said yes and saw that both of them are even. So this would reduce to, well, they both have a 2, so this would reduce to 11, and this would reduce to 18. So 11/18. And then we would ask, well, does 11/18 reduce any further? And the answer should be no. Again, 11 is prime, and that means the only way it's going to share a factor with 18 is if 11 is also a factor of 18, and it's not, so that is a reduced factor. All right, so 7 also reduced. How about number 8? 3 times 1 is 3. 7 times 3 is 21. Do you see a common factor in there? I see a 3. So 3 goes into 3 once, 3 goes into 21 7 times, and that's it. So 8 also reduced. Okay, number 9. 1 times 1 is 1. 2 times 15 should be 30. Again, this can't reduce because 1 doesn't have any factors other than 1, and 30 has a factor of 1, but it doesn't make 30 get any smaller, so that is it. Okay, and then number 10, 1 times 11 is 11. 2 times 12 is 24. Again, 11 is prime, so the only way that this fraction is going to reduce is if 24 also has a factor of 11 in it, which it doesn't. All right, I'm going to skip over 11 and go to 12. All right, so we go across here. 6, 13 times 3 is 39. Again, if you don't know that, that's fine. You could just do it off on the side. So do they have any factors in common? So we're thinking of all the factors of 6, since that one's smaller. So that would be 1, 2, 3, and 6. So does 2 go into 39? Again, I'm not bothering to check 1. It doesn't make it any smaller. Does 2 go into 39? No. Does 3 go into 39? Yes, it does. We could tell because 3 plus 9 is 12, and 3 goes into 12. Or you could just look here and say, oh, 39 was made up of 13 times 3, so yes, 3 goes into it. So we divide both of them by 3, and we get a 2 and a 13. All right, so this one also reduced. So I want you to go back and look at those 4, numbers 6, 7, 8, and 12. I'm not going to ask you to do this. I'm not going to tell you right now. I want you to think about it. But what is it about those that made them reduce? Right? Could you tell ahead of time that that was going to be something that reduced, or did you really not know until the end? And if you didn't know until the end, see if you can go back and think more why maybe ahead of time you would know that it reduced. Second thing is, this question I heard came up about the decimals, and it's true for both decimals and fractions. We are used to multiplying numbers and making them bigger, but when we multiply by fractions and decimals, sometimes the answer is smaller than what the original thing was. And I want you to think about that. I'm going to draw up here. Let's say I drew 6 cookies. And I wanted to take half of them. The multiplication that we would do would be 6 times 1/2. Right? And the answer would be, if I want to get half of 6, the answer is going to be 3. There is an instance where I've taken a number and multiplied it by a fraction, and I ended up with something smaller than I started with. I started with 6 and I ended with 3. Why is that? Well, it's because you're taking a piece of that. All right? So half is something that's less than the whole, and so I'm going to get less than 6 right here. So if I wanted half of these cookies, that's what I would get. All right? So when you multiply by something, either a fraction or a decimal, that's less than 1. All right? So in fractions, that's a proper fraction, and in decimals, that would be something like 0.56 or something like that. That is also a fraction less than 1. I'm sorry, a decimal less than 1. And what that means is you're taking a piece of the thing that you were multiplying by. All right, a piece less than the whole thing, because 1 is the whole thing. If we did 6 times 1, we would just get 6 back. But if we did anything less than 1, we get less than 6 back. So in fractions, again, that's a proper fraction, and in decimals, that's going to be a decimal where it's just numbers after the decimal. In front of the decimal, it's either a 0, or sometimes people just write it as 0.56 and don't write anything. So it's got to be less than 1. All right, so that's why that happens if we that we would take and get a product and it would be less than 1. And if we have something where it's 2 fractions, like let's say half of a third, It's going to be even smaller. It's 1/6. So here is the third. And I want half of that. All right, so I get something even tinier than what I started with. All right, so hope that helps. All right, bye.